Hello and welcome to week 2. For this video, I'm going to cover some problems that deal with conversions with the objective of being able to apply conversions to real-world problems. My hope is that this helps you with your application assignment. And the first thing I want to point out, I did post in an announcement the Joyce conversion factors for Math 125. And in particularly, I'm going to be using a few formulas for these problems. Okay, so I've kind of highlighted them here on the conversion sheet. And let's go ahead and get started. Number 1, an IV flow rate is set at 5.2 milliliters per minute. What is the flow rate in liters per hour? Round your answer to the nearest thousandth. All right, so I have to convert 5.2 milliliters per minute to liters per hour. All right, so there's more than one approach to this, and you may choose to do something different. The first thing I like to think about is the whole time thing. So if it's 5.2 per minute, to figure out how many milliliters per hour, which is something that I would want to know, I can go ahead and multiply the 5.2 times 60, since there are 60 minutes in an hour. Okay, so I'm going to go ahead and do that. I'm going to do 5.2 times 60, because there's 60 minutes in an hour. And what that will do is that's going to give me how many milliliters per hour, which is useful because now I have to figure out how many liters per hour, and at least I already have my time converted. Okay, so from here, I'm going to now do a proportion for you, and I'm going to use my conversion sheet. So based on my conversion sheet, I know that there is 1 milliliter is equal to 0.001 liters. Okay, so that's given to me on that sheet. And there is a lot that I can do here. So before I go crazy and set up a proportion, there is kind of a faster way. If 1 milliliter is equal to 0.001 liters, but I'm given 312 milliliters, then it makes sense that I could actually just multiply the 312 by 0.001, and that would give me how many liters I have. So I'm going to go ahead and do that. And since this is happening, I can actually just move the decimal over 3 decimal places as well. But that would be 0.312 liters. Okay, but that is just a simple approach. If I want to set up a proportion, I sure can. And you do set up proportions for other problems. So I'm going to go ahead and show you what it would look like with the proportions. That was one way to do it. The other way would be to use your conversion to create a proportion. So I know that 1 milliliter is equal to 0.001 liters. And so that can go on my left side. And then on my right side, I'm given the fact that there's 312 milliliters per hour. I was really given 5.2, but I had to multiply by 60. So I can actually put 312 milliliters on my numerator because I want that to match. So that's how I would line it up. Now what I'm trying to find are liters. So X is my unknown. That's what I'm trying to find. And in this case, I should get an answer in liters. From here, I can cross multiply, which I'll do in green. So I'm going to cross multiply. And then I'm going to have 1 milliliter times X is equal to, and then now I have this whole thing times this whole thing, right? So that would be 0.001 liters times 312 milliliters. And I'm writing it in parentheses to show that multiplication. Okay, now from here, I need to solve for X. And I can go ahead and multiply my numbers together, right? So 0.001 times 312 is 0.312. But we would have left over, we would have our units, which are liters and milliliters. And they'd kind of just be sitting there for a second. And that's equal to 1 milliliter times x. Okay, I am trying to get x by itself. So I now can just divide both sides by 1 milliliter. And then on the left side, it cancels out to just x. So that's going to be my unknown. And then over here, notice that it's just 0.312 divided by 1, right? So that's just not really going to affect the 0.312 part. But notice my milliliters cancels out. And I'm truly left with 0.312 liters, which is what I was trying to find. All right, let's try another one. So this one says a medication states the patient dosage is 32,450 micrograms per day. The medication is stated in milligrams. How many milligrams should the patient receive? Round to the nearest milligram. All right, so I need to use the fact that 1 microgram is equal to 0.001 milligrams. Okay, so I'm going to use this from that sheet. Okay, so this is kind of like, I need to use that. Now, I can go ahead and set up a proportion, or I can just think about it, right? So 32,450 micrograms is equal to something milligrams. And so if 1 is equal to 0.001 milligrams, then 32,450, I could just move the decimal over 3 to the left, or just simply multiply it by 0.001. However, I can see that could confuse people. So I'm going to do a proportion, but I can already tell, and so I can already tell that this is going to be my answer, 32.450. However, if we round to the nearest milligram, then it would be 32. Okay, so that's one way to approach it, but let me show you the proportion just in case. So for my proportion, I would do 1 microgram over 0.001 milligrams, that's my given, is equal, and then since they gave me micrograms here, that will go up here. And then my unknown would be on the bottom because I'm trying to find milligrams, right? So that's how I get the x. Now I can cross multiply to solve. I will have 1 microgram times x is equal to 0.001 milligrams times 32,450 micrograms. When I multiply this together, I get 32.450 mg in Cg is equal to 1 mcg times x. Then I divide both sides by 1 mcg. 1 mcg cancels out, and I'm of course left with that 32.45. It does tell me to round though to the nearest milligrams, so that would be 32 milligrams. All right, let's try another one. Number 3, a medication is dosed at 12 milligrams per kilogram. How many milligrams should a 90 kilogram patient receive? Round to the nearest milligram. All right, this is definitely, I would say, cause for a proportion would be a good way to do this. So I'm going to take what I know, which is 12 milligrams over kilograms. And really, I know there's no number in front of the kilograms. That's just assumed to be 1. So that would be my left side. And then my right side, we are given the weight of the patient, which is 90 kilograms. Make sure that when you do your proportion, the 90 is going to match and both be on the denominator. And then the x is our unknown. And we know that our goal is to get to the milligrams. Okay, so I'm going to cross multiply, and I'm going to take the different values with me here. So when I multiply the 12 milligrams times the 90 kilograms, I'm going to write it as 12 milligrams times 90 kilograms is equal to X times 1 kilogram. And I'm going to multiply 12 times 90, which is 1,080. And then I really have milligrams, kilograms is equal to 1 times X, which is just X, kilograms. And then to get X by itself, notice I would divide both sides by kilograms, or by 1 kilogram if you want to think of it like that. The kilograms cancel out, and I'm left with 1,080 milligrams. And it was already, in my case, it was already rounded to the nearest milligram, so I would just be done. Number 4, a medication comes in 100 milliliter bags containing 10,128 milligrams medication. If the patient requires 354 milligrams, how many milliliters should be administered? Round to the nearest tenth of a milliliter. All right, so I'm going to definitely want to set up a proportion here. So I have 100 milliliters, which contain 10,128 milligrams. Okay, and then what else am I given? Well, I'm given 354 milligrams. That needs to go here so that it matches on my denominator. And then the unknown is the milliliters. So that's where I'll put the X. So the X will be, of course, the milliliters on the top. Then I can cross multiply and solve. So I'm going to have 100 milliliters times 354 milligrams is equal to 10,128 milligrams times X. Okay, from here, I'm going to go ahead and multiply 100 times 354, which is 35,400. So I multiply my numbers, MLMG. That just kind of, they're being multiplied together, but it kind of just drops down as we're going to solve. And then over here, I have 10,128 milligrams times X. I need to get X by itself. So I need to divide because this is multiplication. So I'm going to divide both sides by 10,128. Notice the milligrams do cancel out, and you know what? I think I accidentally added a number here. I'm sorry about that. Let me fix that. Okay, that's 1,128. There we go. All right, so I'm going to take the 35,400 and divide it by 10,128, and I get approximately 3.495. But I'm rounding to the nearest tenth. So this is the tenths place, and that is a 9. So it's actually going to round up to 3.5 to milliliters. Okay, but notice my milligrams do cancel out. And so that's always like a great way to check it. What you should have remaining is what you were trying to find, the unknown. All right, number 5. According to Soccer Buzz, 15% of a subpopulation like to play soccer. In a group of 352 of the subpopulation, how many will like to play soccer? Okay, so 15%, we can always write percents out of 100. So I could do 15 out of 100 is equal to, and then we're trying to figure out how many people, and we know that the population is 352. So I'm going to have the percent, but I can always change it to how many people out of 100. So 15 people out of 100 represents 15%. And then I'm trying, and they like soccer, and I'm trying to figure out how many like soccer out of the 352. And so I can cross multiply to solve. So I can cross multiply here, and I have 15 times 352 is equal to 100 times X. 15 times 352 is 52,800. I'm sorry, 5,280, my goodness. And then that equals 100 times X. Divide both sides by 100, and I get 52.8. And if I round that to the nearest person, it would be approximately 53 people. All right, I hope this video helps and I hope you have a great day. Bye.